Okay, so this is Miss Ambrose. I had recorded these first two problems and it was great, and then for some reason it got deleted. So I'm going to knock out these first two problems again and do my best to explain myself the way I did the first time. So, okay, for the first problem, you're doing multiple transformations, a rotation of 90 degrees, a reflection over the y equals x line, and a dilation by a scale factor of 2. So I would write out the rules, okay, for each step so that you can just take your coordinate and apply the rules each time. So to help you remember the rules, okay, for rotations, you can do this card trick where you've got, let me focus that, where you've got an x and a y, and then on the back side, you've got negative x and negative y. Each time you rotate 90 degrees, our default rotation is counterclockwise, so you take this side and you give it one turn for each 90 degrees. So the 90-degree angle rule is negative y comma x. The 180-degree rule is negative x, negative y. The 270-degree rule is y, negative x. And when you've gone a full 360, now you're back to where you started at x, y. Okay, that's rotations. For reflections, the way that I like to remember reflections is that if you're reflecting over the x-axis, then the x won't change. It stays the same. It's the y that changes sign. You can also just think about it logically, okay? If you're reflecting over the x-axis, and we're up here, okay, the position along the x-axis isn't going to change, but it will go from being positive to being negative, so it's going to change along the y-axis. Okay, for y, it's the opposite. You change the sign of x, leave y alone. For the y comma, or the y equals x line, I remember it because it's the same order. Y equals x, y comma x. For y equals negative x, it's just like this rule, but this time negative. Negative y and negative x. Okay, so now let's take each coordinate and apply these rules. So A starts out at the coordinate 0, 3. Okay. Rotation of 90 degrees. The rule is negative yx. That means you're going to flip the coordinates and change the sign of y. So that becomes negative 3, 0. For our next one, reflect over y equals x. So the rule is y comma x. That means these just switch places. And then last, a dilation of a scale factor of 2. So we multiply that by 2. Our coordinate is 0, negative 6. Okay. All right, for coordinate B, let's turn this around. So B right now is at the place 4, 0. Okay. So then first rule, negative yx, we're going to switch them. Okay. Now you're supposed to change the sign of y, but y is 0, so it's not going to change sign. Okay, now we flip it back because of the other rule, and then multiply by 2. So this becomes 8, 0. Okay, and the last one is C. Ignore all this. Okay, so C is at 0, 0 right now. If we apply this rule, well, it's just 0, 0. If we apply this rule, it's still 0, 0. And if you times it by 2, it's still 0, 0. So that means that C never changes place. It stays at 0, 0. And I want to bring up that, when we're doing transformations, our default center for every transformation is at 0, 0. So if your point is at the center, then your point's not going to move because that's the center of the transformation. So C is where it was. A is now at 0, -6, and B is now at 8, 0. So here's A, and here's B, and there's our new triangle. Okay. Number 2, the coordinates A at -3, 5 and B at 4, -8 were transformed by the following rules. Give the new coordinates for each transformation. So really, all you need to do for these is take your X and your Y and plug it in and get your answer. Okay, so like for A, okay, the X for A is -3, so 2 times -3 means that our new X is going to be -6. Okay, for Y, 2 times 5 minus 3 gives us 7. So that's our new coordinate. I'm going to stick with A first, and then I'll do B. Okay, so for A, notice it switched the X and the Y. Okay. So that means that we need to take our Y coordinate and do that first. 5 plus 1 gives us that our new coordinate will be 6. Take your old X, -3, subtract 4, and now this is -7. Okay. All right. Sorry, there's a bit of a glare there. 3 times a -3 gives you that your new X will be -9. Plugging in Y, 2 times 5 plus 3 gives us 13. And then last one, -yx, so that means they're going to switch places. And then your old Y changes sign, so it becomes -2. Okay, and last we've got B. So for B, same idea, it's just you're going to plug in 4 for X this time and -8 for Y. So 2 times 4 gives us that this is 8. Okay. 2 times -8 minus 3, -19. Okay. So again, this is your Y coordinate that you're plugging in here. So -8 plus 1 gives us -7. And 4 minus 4 gives us 0. Okay. All right, so we've got 3 times 4, our X gives us 12. 2 times -8 plus 3 gives us -13. And last, take your X and your Y, switch them up. But our Y changes sign. So originally it was negative, now it's going to become positive. So really you would write it as 8, 4. Okay. All right, so the rest of this is going to be in the next video, and I'm going to put these in a playlist so they should follow each other, one after the other.